Good morning, everybody. This is Thomas Ott for NeuralMarketTrends.com, and welcome to my 9th video tutorial on Rapidminer 5.0. In this video, we are going to continue with what we started in video number 8. We're going to learn on how to use Rapidminer to do some financial time series forecasting. In the last video, we did some basic data discovery analysis where we created a nonlinear trend line. We did some basic prediction series, and we also looked at creating a moving average. I hope you enjoyed that video and fooled around with it. There's quite a bit you can do with Rapidminer and some time series data. So let's get started. We're going to continue on using the same data that we did in the last video. Let's run it real here. It's the S&P 500. We have a date, open, high, low, close, and volume. You can see here there's something about almost 1,000 data points, or 1,000 example rows of data. Okay? And what we want to do in this video, let me take a sip of coffee here, is we are going to prepare the data to be loaded into a time series model. Now, time series data, as by its definition, it's essentially a set of data points in time, and we're using daily data of the stock market, of the S&P 500. And we're going to load it in such a way that the model is going to try to learn the various waves or sine waves or representations of the waves to try to predict the next day for the S&P 500, or to give an idea on how well the model can be built to give you an accurate prediction trend. So in order to use Rapidminer and time series forecasting, and to build such a model like that so that you can predict against later on, like say using some out of sample data, you want to use a different set of operators under series. The first one is the windowing one, and that's perhaps the most important one. So I'm going to drag this windowing one over here. And let me back up a little bit and give you a little explanation on windowing. In the old Rapidminer 4.x days, whatever version it was, they did prepare a time series set of operators, and there were two of them. One was a univariate model, a univariate operator, that was able to look at one variable and try to create a model from that. And the other one was a multivariate one, where you would have multiple attributes, multiple variables trying to explain the output or the label variable. What Rapidminer did in this version of Rapidminer is they created the windowing operator, and they said you could use both univariate and multivariate. And in our case, we like multivariate because in stock market data, you have open, high, low, and close. There you have it. Okay, before we begin, I want to also add in a set roll operator, like what we did in video 8. And I want to set the date as an ID. It's just what I do. Now let's go look at the windowing operator. This one is a very interesting one, and it is often most understood, and yours truly makes mistakes on this too a few times, because it's a little different way of looking at things. What we're going to do here is we're going to look at these couple of parameters which are important, and it's important to understand them right away. Series representation. The way the data is set up, you can either load the data into the model by encoding it by examples, which is what we want to do, because each example is a row in the spreadsheet that has one particular data series point of data. The other one is encoding the series by attributes. We normally don't do this, but you can if you want to, where you can load in each attribute based on a time series, based in time, into the model. Next, we have the horizon, and this is the prediction horizon. This is what you want to train the model to. If you want to do it 1 day ahead, 10 days ahead, or what have you. This is where the model will be built and try to determine the accuracy. So in this case, we want to predict 1 day ahead. Now the window size is perhaps the more trickier one of them all. In the window size, we'll do this as 5 for now. You'll see we'll change it back down to, I think, 0 or 1. One of them. This is the one where I always forget. This is where the windowing operator here will take a window snapshot of your data. And before we do that, let's just take a look. I'll give you an explanation of what this does, what the windowing snapshot is. Let's run this real quick. Go to data view. Here you have the date. Open, high, low, close, volume. This is one example row. This is what we want to encode. If you want to encode by attributes, it'll encode it this way, right? Which is what we don't want to do. When we set the window in the windowing operator, the window will say, okay, I'm going to take 1, 2, 3. Let's see, we set it to 5, right? It's going to take 1, 2, 3, 4, 5. It's going to load these 5 points into the model as one window, and then it's going to slide it ahead by however we want to define it. Slide it ahead by 1. It's one row, so it's going to go 1, 2, 3, 4, 5 again. So it's 5. Build the model on this. Train the model on this. Test the model against it, and then slide it ahead one more for a snapshot of 5. So the window you can set. You can set the window to 5, to 10, to 100, to whatever amount you want. Okay? So let's go back here. And we're going to, let's go get the window operator again. The windowing. Drag it over here. We're going to encode. Okay, horizon is 1, and we're going to do, let's do 5. Step size, this is where you want to move the window head. You move it ahead by 1 step. We are going to create single attributes. We're going to create a label, which is our output, which we're going to select here. Label attribute will be close. Okay? Let's run this model. Let's see what happens. Here we go. Here's the label. Dun, da, da, da. And here's the date, the ID. And look at this. It loads in 5 open variables for this time snap. 5 highs, followed of course by 5 lows, and 5 closes, and 5 volumes. So this is not necessarily representative of what we want to do, because here it'll load in this one example row, these 5 opens, these 5 highs, these 5 lows, 5 closes, and 5 volumes to try to explain this label, this particular close. Not exactly what you want to do, at least for me. And then it'll skip ahead and it'll do that, vice versa, and keep sliding down. So let's go back and let's modify the window size. Let's go. I think it's 1. This is where I always screw up. 1 or 0. Let me try this here real quick again. Yes, it is 1. So here we go. Here we go. Here we have the label. This was the close of this particular date of the S&P 500. Of the open, high, low, close, and volume. And now we are going to train the model using these multivariate data on this. Build this, and then we're going to slide the window ahead by 1. I'm going to keep doing that and testing it. This time we're going to do one window at a time. Train, test, train, test, train, test until we get to the end of the data. Okay, let's go back here. Now we have pre-processed, prepared the data to be loaded into a model. Now we're going to go ahead and we're going to create a validation operator, just like what we always do. We're going to split the data into a training and validation set. We're going to put a neural net. In this case, you can also put a support vector machine if you like. But we're going to do a standard neural net, and we are going to do a performance evaluation and try to get that information. Okay? So, first things first, you have to use the sliding validating operator in the time series section, because what we want to do is we want to keep sliding the data across the time series and keep building and validating and fixing the model and trying to get it to converge as we slide across this whole 900 data points. So that's over here. So we go under evaluation, validation, sliding window validation is what we want. Come over here, train it. Let's go set the training window width. In this case, we're going to do, let's do 5, sliding it by 1. Test window width is 5. The horizon is 1. We're going to do cumulative training. Let's go get a neural net. Neural net, okay. Put it in here. This is the same as all the other ones, except you are getting this sliding validator from the series folder. Okay. And now let's go do apply model, as we always do. Right? Okay. Drag it over here. Connect them. And the difference is we're going to do here, instead of using standard performance operator, we are going to use a special one for forecasting. And that is located under evaluation, performance, forecasting here. This guy's a little tricky. This guy's different because, oops, wrong one. Because you have to select the horizon, so 1 day ahead. This is what we want to do. Okay, prediction trend accuracy. Okay, good. I think we're all ready to go. We are all ready to go. So let's run this model, and then we'll call it a day, and I can go to work. Uh-oh, ding, 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 ding. Let's see here, what happened? Oh, see here, here's my mistake. 1005. I meant 5. Here we go. All right, let's try that again. I'm trying to remember how long this will take, how long this model process will take, but I don't believe it's long. Oh, you know what I forgot? Let me go back here. I forgot to connect that. This will give me the performance output. So let's try that again. Well, I have you guys here waiting. Haha. If this process runs longer than 30 seconds, I'm going to probably pause the video and then start it up again as we wait, because I really don't have a lot of time to wait here. Oh, there's 30 seconds. Okay, I'm going to pause the video. I'll be back shortly. Okay, I'm back. After 19 minutes and 20 seconds, the model has finished. So as you can see here, that if you have a large data set and you want to run these models, you probably need a lot of memory or a lot of computer horsepower to do so. In this case, we had used 992 example rows of the S&P 500 starting sometime in April 2006. So let's take a look what we got. We have a performance vector and the example set. This is what was windowed. Let's check it again, make sure everything was okay. There's our label, the closing date, open, high, low, and close, and volume, and successively down the line here. So let's look at the performance. This is what we want to see. Aha! Prediction trend accuracy, 0.41. That's not very good, folks. But it is what it is. And remember, in video 8, I had informed you that forecasting time series can be a dicey business. So how do we try to bring this prediction trend accuracy a little bit higher, say to 0.6 as a minimum? Well, there's things that you can add, like other indicators or fundamental values into your example set and have it train on that. That's one way of doing it. Another way of doing it is perhaps taking a shorter time frame, perhaps the last 2 years. Because as we know that trends change over time in the market, and sometimes my whole data set here going back to 2006 predicted, or I'm sorry, not predicted, caught the trend going up and then caught the trend going down, so the model is probably going, what the heck's going on here? So that's a word of caution. In my next video, video number 10, the final one, we are going to use some out-of-sample data. We're going to create a prediction experiment. We're going to learn a model using this setup, and then we're going to also take this model applier here, this model guy, and attach him to something down here that we're going to build, which will be the prediction set. So you can run the training and the prediction in one experiment now. And you don't need to use a model writer or model reader anymore. You could if you wanted to, but you can just directly output it into here. So, I'm heading off to work. This is Thomas Ott for NeuralMarketTrends.com. Thank you so much for watching and for commenting and for giving these videos some great review. I really appreciate it. I'm looking forward to closing out the first 10 and taking a break, a well-deserved long break, before I start up again. If you have any questions, come check out my forums, and I'll talk to you soon. This is Thomas Ott. Have a good day.